First off, I want to thank Takt, specifically Jason and Spencer, for showing me better ways to use Takt. It wasn't my first time learning it, but wow, what enhancements. Can't say enough good things about it. What can we do in less than 15 minutes? We can design a plan that allows us to get workflow, trade flow, and logistical flow, all on a single sheet. For those of you that don't know, in German, the word Takt means beat, frequency, or regularity to which something gets done. Let's check out this animated video to learn more compliments of Takt.
The Takt production system is a scheduling system that maps flow through rhythm, continuity, and consistency on a time beat, or takt. The system stabilizes the project so you can optimize it. It is made on one page, showing all three types of flow in construction, because it is formatted in time and space in what is called a takt, the base unit of takt planning. These takts allow you to level work and create buffers so you can absorb interruptions and variation. We create buffers by using Little's Law, which is takt wagons plus takt zones minus 1 multiplied by the takt time, which equals the duration. We're able to identify the right zoning to optimize your schedule and find those buffers. Without this, you're just wasting time with large batch areas. This format removes the chaos, the pushing, and the wasted resources of CPM. It holds the project to a one-process flow with leveled production. It ensures you have a reasonable overall total project duration. Trade flow is the key to this. You must have high levels of trade flow and workflow in construction. Trades flowing means work is flowing, so only a scheduling system that shows both types of flow will work for you and your company. You need over 60% workflow, over 80% trade flow, and over 20% logistical flow. This ensures we reduce excess worker counts and material inventory, which makes you more money. Takted projects have smoother finishes. They need less manpower and materials, and they make more money. This is because the takt rhythm creates the backbone where the team can win in a balanced and fun way. Are you ready to make more money, use less manpower, stabilize procurement, and reduce the load on your team? If so, it's time for takt planning on your project. Remember, flow where you can, pull when you can't, and stop pushing. Takt time is the basis for construction scheduling. Systems like Scrum and Last Planner are pull systems that align everything else to the takt rhythm.
So takt planning is a lean construction framework to enable critical flow schedules that focuses on information and work, throughput and bottlenecks, and some people call constraints, to enable flow. Why should you care? Because construction is complex. No matter if you're an architect, an engineer, any type of designer, an owner, a general contractor, trade partner, schedule and budget for the typical construction project. 3 out of 4 jobs are late. 75% are late for at least 40% of the total construction phase duration. And 3 out of 4 projects are also over budget. Over 90% of construction projects finish with 30% cost overruns. Ouch, that's the typical. It's even worse for projects that are $1 billion or larger. Research shows that communication is key and critical. 8 out of 10 owners cite the need for better collaboration with contractors, and about half of project-related rework and 10% of time increases to project schedules are caused by rework. That's the current state. And also currently, we have projects utilizing Scrum, Last Planner system, and Takt. We see industrial and manufacturing construction projects being completed 70% faster than CPM schedules indicate, 50% faster for residential and multifamily, and 25% or more faster for commercial construction. What great news. Thank you, P2SL and Takt, for sharing those metrics. This is where it is across the planet. And I know that there are even more. So feel free to pause and find your country, or be the first to start it and get on the board. From Takt, If you take a typical critical path method schedule and just push it into a spreadsheet, and you'll see that what we have is a lot of stacking. So each color represents a different company. We've got areas on the left, or what we typically see in CPM work breakdown structures, and we see we've got stacking in order to make the schedule happen. Yes, the schedule says we'll finish, but it says that we're working simultaneously in 5 different areas. That's the typical thing we see, stacking. In pool planning, if I just come down a level, or last planner system of production controls, we might organize the areas from 1 to 5 and create some trade flow here, not getting people stacked, but we see we have some opportunities where we have these gaps of waiting. If we take the Takt approach, we can organize ourselves in such a way that we can do one area after another without stacking the trades or disciplines. Here you see it, nice, sequential, all the way to the end. And we might even introduce the concept of buffers, or typically what we say in CPM language, float, to handle excess variation. This is an example from Lean Takt, and they gave a nice key example. This is a 1-page schedule that you can see spans about 1.5 years. I've got year on the top. I've got my time. I've got my location. I've got the tax zones called out. We've got an exterior separate Takt here from the interiors. We have exterior happening, and then we get enclosed and we start to really go after low risk interior construction, as well as later picking up the site. Each one of these represents a tack wagon, as you saw in the video. And here you can see all the different trades we have, very easy to see in a glance. Here we have the structure on a more traditional path, not takted, but still visually indicated. I've got from Lean Takt a couple of manufacturing tacks. This is a 1, 2, 3, 3.5 year project on a single sheet. And then here's another manufacturing example, and it's blurred out to protect the teams, included color-coded maps on top. And we've got the main bulk of the schedule activities here, pictures, model images, and colored elevations so that people can see where we are and where we're going. Batch size absolutely matters. 3 different types of work, a customer order of 10 finished goods. Each activity is going to take 1 single day in this example. This step takes a day per unit of work. Step 2 takes 1 day per unit of work. So there's 10 days here, 10 more days here. And step 3 takes 1 day per unit of work, 30 days before the customer gets the 10 finished goods. What does that look like in the schedule? Well, there's sequence 1 going for 10 days. Then we have sequence 2, days 11 through 20 for step 2. And finally, they turn all that over for sequence 3, going from days 21 to 30. Now, if I cut that in half to a batch size of 5, I'm still working 1 single day per item. But after 5 days, the team working on step 1 hands it over to the team working on step 2. And then they'll work for 5 days before they hand off. And the customer at the end is going to get this 33% faster for a total duration of 20 days. Let's see what that looks like. So step 1 starts to work for 5 days. They hand off 5 things to step 2. You can see that they continue working on items 6 through 10, and they do another handoff 5 days later. But here, after 5, they turn over to the final team on step 3, and they work for 5 days, and then continue working an additional 5 days, finishing after 20 days total. That's 10 days faster, or 33% faster in total. But what if we tack this? Every day we work is a single day before we hand off to the next step. 60% faster in 12 days. What does it look like? Here we've got step 1, step 2, step 3. They're handing off after each day. I'll come back to this pink in a second. Step 1 team has uninterrupted flow, day 1, day 2, day 3, all the way to 10 days later. And they're handing off at the end of each day to the next step. So this customer receives the order 12 days later, 60% faster. Now, what happens if I don't perfectly tack this out and we have some variation or some process step change? No worry, we can make this adjustment. If I add these 2 days at the end here, if I cascade the 2 days down across every single row, at the very end, I've only increased the schedule by 13, 14, 2 more days. Let me zoom back so you can see that it's lining up exactly at the 14 mark. So there's day 14. That's a theoretical example. What about a real example? Here's a manufacturing construction project that we implemented Takt. On the left, we've got some engineering activities. We've got the time on the right. I took the critical path method schedule and put it into this Excel spreadsheet, and it took me about 1 day. And this is multiple buildings on a very large site. I mean, this building right here is over 1 million square feet. And I'm just showcasing one area. This is the typical critical path method schedule. I put a bar on the top just to show the total construction time in blue. Each one of these columns represents a week, and it ends on October 16th before the start of commissioning for just construction activities only. And we've got foundation work. I'm only blacking out the name of the building. Structural steel at grade, structural steel at the second floor. Then we've got metal decking at the penthouse level. Finally, we've got the exterior siding, slab on deck on the first floor, and then we have, this is a lot of electrical and mechanical scope. You can see these 2 bars overlapped for electrical and mechanical installation items. Traditional commissioning schedule here happening to the right. So the owner is going to be able to utilize this building for its purpose as early as January 15th, when there's no more construction happening. Now, using the concepts of Takt, like you saw in the simple example above, within 15 minutes with the trade contractors and the superintendent, could we break this 1 million square foot building into 4 areas? And we just called them area A, B, C, and D. And they said, yes, we can. And so by doing that and using known production rates that this was built on, when the schedule was first created, we broke it up into these areas. Now you can see foundations here. Then we go into electrical, mechanical, underground. There's a little bit of it. Then we go up to grade, and see, we didn't even have that here in the CPM schedule. Now we've added, that's an enhancement. We've added that in to catch that work that's going to happen with the foundations. Then we go up to the second floor metal decking. So you can see we've got the same sequence. We've only categorized it here with this simple 1 million square foot building in 4 areas. Once we start the foundation work, they stay on site all the way to the end. They go to work on other buildings on this very large campus. They come back to pick up the slab on metal deck, and then the slab on grade is the last thing that happens based on the constraints that this engineering design requires. We've got a couple of days of buffer, and then we come into this siding, which is what this S represents, wrapping around the building and these following these 4 different areas. And remember, this is just a first pass schedule. And then we finish here and start commissioning 4 months faster. That's 23% faster. And this was just a first pass schedule for 1 building. We kept the same commissioning sequence because we didn't have anyone from the commissioning team to speak to what we could do here. One very cool thing that came out, both the mechanical and electrical trade partners said, you've leveled the work for us. So now we'll have the same crew starting and finishing the entire building, no mobilizing changes or fluctuations in crew size. We know based on experience that doing this is going to allow us to increase our quality and increase the safety for everybody. So you see, if we focused on trade flow only, we'll have these huge gaps. If we work on workflow only, like we do in a critical path method schedule, but if you combine both together, you can have trade flow and workflow. And now we also have logistical flow through the site. We know staging of materials. We know high levels of certainty when we're going to actually need things. And we also check this against procurement, which some things are going to take over 1 year to get on site. Manufacturing construction project, 1 day to decompose the critical path method schedule into this lean Takt template. And then 15 minutes, we made a first pass Takt plan with the electrical and mechanical trade partners and the project superintendent. 4 months of schedule time. If you want to dive deeper into that, I highly recommend Elevating Construction Takt Planning, where I guest contributed a chapter on Scrum. And if you want to connect with me or pick up my book, head over to thefelipe.bio.link or hit that QR code on the screen. It's time for you to get started and make things easier, better for construction.